tomorrow is it's individual, and the test on Thursday is with a partner, and that's going to be more focused on AP questions. So this thick packet here, these are AP questions. These are samples. I do not have the answers up online yet, but they're in Blackboard, but I'll go ahead and get them up, okay? So that you'll be able to see the scoring rubric. It is, but you can go to the originals and look at it if you want to. Because they have me restricted, that's what I do, so I have to use a snippy tool, yeah. Yeah, not particle motion where you have to graph the particle's motion, but that's right on here. And we'll start with the yellow sheet and go over that, and then I'll highlight this. And what I don't get through, if I don't get through it, I have it recorded in period 2. I'm recording in this class too as well. But so we'll go over this, and you're going to see a common theme when you do these. So it's kind of nice, because all of a sudden you're going to go, oh, that's exactly the same problem we just did. It just looks different. So do we need to see the first problem? I'll give you a chance to try it first.
Did you want test corrections?
Yes. I don't need test corrections.
Yeah.
I'm going to draw a picture of what's happening. Okay, the fly is crawling from left to right along the top of the curve, 7 minus x squared. What does that look like? Parabola. Starts at 7. You know what? I think I want to know where this point is, because I know the fly is at 4, 0, and I need to know where that is. So I'm going to find the 0 of the function. Remember how to find zeros. You set your function equal to 0. And so x squared equals 7, so x equals the square root of 7. Well, I still don't know what that is, but I do know that the square root of 7 is between the square root of 9 and the square root of 4. So it's between 2 and 3. That's what I really like to know about square roots, not how to simplify it. So I know this is right, maybe 2.2 or whatever. So my fly, or my spider, excuse me, is over here at 4, 0. Now, there's my little spider. Okay, my fly, which I can't draw, is up here. And the thing is, you guys do know light travels in a straight line. Light does not bend. Or if you didn't, you know it now. Well, that's one of the questions, but in classical mechanics, it doesn't bend. Okay, so if you're up here, you're going to see this. I'm not going to see the spider, am I? I'm going to keep coming down the curve here, and maybe someplace, it's getting closer, right here maybe, a tangent line, which is not a very good picture, but that's the tangent line there. My picture's not great. What's that ordered pair? It's x, y, right? So now I just got to figure out something, because I want to find the distance between this point where he first sees the fly, or the spider, and this point at 4, 0. Well, I need to know what x and y are, so I need to have an equation to solve. There's got to be something I can say that's true about this, so maybe I can figure out what x and y are. So it's the only thing we know about. Remember, this is a calculus class. I know slopes. Slopes. Can I find the slope between x, y, and 4, 0? It's y minus 0 over x minus 4. Okay, that's the old way that all the Algebra 1 students should be able to tell me. But you guys are smarter than that because you're in calculus. And if y is equal to 7 minus x squared, what's the slope using calculus? The slope is the derivative of this, right? So it's negative 2x. And then some of you are saying, well, okay, that's great. I still have a y in there with my x's. I only want the x's right now. I either want x's or y, so it's like easier to get rid of y. But I do know what y is. This is the aha moment. I have it written right here. What is y? 7 minus x squared. So now you're going to get 7 minus x squared over x minus 4 equals negative 2x over 1. And when you have two fractions that are equal, those are called proportions. You remember how to solve a proportion? Cross multiply. This rest of this piece is all algebra. Where was the calculus? That was it. The calculus isn't the problem. Okay, so it's 7 minus x squared equals negative 2x. Do I need parentheses? Yes. No invisible parentheses. So it's 7 minus x squared equals minus 2x squared. What's the sign going to be? Negative 2 times positive negative 4 plus 8x. If you want extra practice, come to my pre-algebra class in the morning, help my kids, because that's what we're doing. And they're having a hard time with it. Okay, now I like to keep my x squareds positive, so I'm going to move all of these terms over here to the other side. So to get rid of the minus 2x squared, I'll add 2x squared. Mixture. So I'm going to get 7 plus x squared equals 8x. I want the 8x over there too. So I like my x squareds first. Okay. Now, the other class says, and it was very good of them to think of this, this proportion here, this is something that I don't think you've thought about. But the solutions to this is not the same equation as this quadratic down here. But the solutions that work in this quadratic might be solutions that work in that one. Solutions are numbers that make the sentence true. So you do have to look for extraneous solutions. Because when I transform it, there can be some problems. First off, x can't be what number? 4. So if I got a 4 here, I'd throw it out. So it's not the same function. But the candidates, the solutions for this one, are candidates for solutions for that. I don't know that that's stress to your math career. But we'll factor this x minus 7, x minus 1. Can we factor it that fast? Please say yes. Okay, what's x equal to? 7 and 1. Now, I want the point on the curve where the spider, no, 5 first sees the spider. So well, let's look at my picture. Is it 1 or is it 7? It's 1. So x equals 1. What's y equal to there? 7 minus x squared. 6. Well, the 7 is true. But the problem is, let me see if I can draw a better picture. If we've given it to you here in class, most likely it's something that's important. Okay, here's the 4, 0. You've got this tangent line. Okay, guys? And you've got this other one. When x is 7, if y is equal to 7 minus x squared, and x is equal to 7, what's y there? 7 minus 49. Okay, it's pretty small. So it's this one. But the point is, the fly is here. He first sees the spider there. He's not going to go down the curve down here and then look back. See what I'm saying? Let's take the context of the problem. This one, 55, guys, similar problem. But now this is just a math problem. So now you do have to look for both solutions. Yes, I haven't finished it yet. Okay. Now, let me show you the easiest way to do distance formula. Here's the ordered pair 1, 6, right? Now, this is kind of a simple example. And then the spider was at 4, 0, right? I don't show my substitution. I don't go x1 minus x2 squared. That's way too much work. It's just Pythagorean's theorem. That's all it is. How far apart are the x's? I don't care that it's negative 3 or positive 3. So I'm going to square 3. How far apart are the y's? And that, by the way, would be a good enough answer. I wouldn't go further. But we will, because we can't. It's 9 plus 36, because if you add this wrong, you're in trouble. It's the square root of what? 45. I don't have to show 1 minus 4 quantity squared. That's too hard. When I first teach it, if I want my kids to learn about substitution and evaluate, yeah. But not now. If I want them to get distance, I want you to get it, and I want you to get it right. If I'm flying that plane, I just want to be right. That makes sense? Yeah, it's kind of scary, actually. Now, how big is that? That's between what perfect squares?
49.
And 36. So it's between 6 and... I'd rather have you have a feel for that. I know that's 3 square root of 5. Who cares? I have a slide rule, I have a calculator. I know it's between 6 and 7. That's what means much more to you. Now, are there other ones you want to look at on this worksheet?
The yellow's
The yellow, I mean? 8. A little different order. Okay, this is like sparse data, but it's asking you for f g prime of 0. That's the product rule. So it's f prime of 0 times g of 0 plus g prime of 0 times f of 0. Now, the notation here might have bothered you. But that's what that means. What's f prime of 0? Negative 1. G of 0 is negative 3, right? G prime of 0 is, and f of 0 is 4. On that pink sheet, on the one that's the pink one that's stapled, you guys, if you turn into the middle piece, 2007, number 3, you can't do B, but you can do A. It's h of x is f of g of x minus 6. You just look at it up on the table. It's like sparse data, same kind of thing. But there's no derivative on this one, because you can't do the derivative yet. So this is going to give you 3 plus 20, and so I get 23. I got it right. Do you need to do the quotient one, or you've got the idea now? Yes, the pass is right there. Don't lose it. Number 5, yeah. If you do the quotient rule in number 5, you can. It's x cubed times 0 minus 3 times 3x squared over x cubed squared. Well, that's 0. And so if you simplify, you don't believe me that it's the same, it's the same. Pardon? You can use the quotient rule. It's negative 9x squared over x to the 6th. And then you could reduce that. It's negative 9 over x to the 4th, which is negative 9x to the negative 4th. They're the same. That's what's nice about math. No matter how I do it, I got to get to the same right answer. Question, Grant? Okay. But I prefer to change this if I can. Sometimes it's not better. You'll figure it out. Let me know what else you want to look at. Then I want to talk you through some of those problems on the AP problems, because this is your first experience with AP questions. But you're going to find a theme. You're going to find a common theme on these, many of the problems, not all of them. Yeah. If I don't get that far, you can look at the video from the last class and just fast forward to the end. And I don't always check my videos, so I got to get yesterday's up. But for sound, so you guys have to let me know. I will get these scanned, give all the details up online. Do you need to see that one anymore? Is this one okay? This is what you're going to see on the exam, on 3 and 4. You're going to see that limit. You're going to say, oh, that's just the derivative of the cosine. Does anybody know what that is? Negative sine. I don't want to expand the cosine of c plus h. I don't want to do that. That's too hard. No, it's fine. You'll just look at it and say, oh, I don't want to cube all that out. It's just the derivative of this. So what is the derivative of this? It's 6x squared, right? And what's the derivative at 5? So it's 6 times 25. Now, your non-calculator section, how much is 6 quarters? 4 quarters is $1. 2 more quarters is 150. Money always works. So that's how you would do the problem. You wouldn't cube that. It would take you way too long. You have 1.5 minutes per multiple choice question. Something like that. But some go like this, and some take a little longer. So all averages out. Okay, are we ready to look? Are we done with this one? The yellow? So we're going to go to the end. Let's look at some of these pink problems. I don't have a smart board. I didn't get there. And I use the snipping tool, so that's why it's not as clear as it should like to be. But if you read through the whole problem, they always do things in context. This is a zoo, and they're doing entries, etc. I'm going to skip all that, although you shouldn't skip all that. But use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at t equals 6. So what is it looking for? This is 2010, number 2. Now, notice it has only A there because you can't do B, C, and D. Not yet. They have to do with antiderivatives. So I want the rate at which these entries are coming in. So I want E prime of t at 6. Because estimate. I'll see if I can do this right. I messed up in the last class. Here's 5. Here's 7. Here's your time. Here's E. What is it asking me for? What is rate? It's the slope. It's just a derivative. It's the slope. You're just estimating. And then it says, show the computations that lead to your answer. I don't care if you can do it in your head. You will not get the point. You have to show it. So what's E prime of t approximately? It's going to be 21 take away 13, right? Over 7 take away 5. It's just a slope. That's good enough. You don't even have to finish that. But what is it? 21 minus 13. So that's 4. So it's in hundreds. So it's 400 entries per hour. 4 wouldn't make sense. I'd have to go see the score in rubric, but I don't think you get the point if you don't have the 100 in there. I'd have to go back and look at it. Did I grade that one? Might have graded that one. When I said I can't remember. That's it. That's all there is. Okay. Now, on 1 and 2, those are calculator active questions. You could have used your calculator to help with the computations, but I hope not. But now, let's look at 2011 question 1. And it gives you the velocity. So you get v of t. This is a calculator active question. It gives you the acceleration, and it actually gives you the position. But I don't really care about that. The question is the speed of the particle increasing or decreasing at 5.5? Is it speeding up or slowing down? How do you find out? Yeah, evaluate v of 5.5 and a of 5.5. And I don't know what they are because I need a calculator. This is a calculator problem. And if they're opposites, then they're slowing down. That's not hard. Where's the calculus in this? Not really. It's more physics. Okay, I don't remember what the signs are. I think they end up being opposites, but I'm not sure. I'd have to look. That's all it's asking. It's 3.4. That was it. No, because they all change. Like this one had the V of t with a sign in it and everything. The falling body problems? No. Radians. Calculator must be in radians. Good questions. Okay, let's look at 2008, question 2. Turn the page. And I'll get these up. You can check them. Use the table to estimate the rate at which the number of people waiting in line was changing at 5:30 p.m. or t equals 5.5. What's it asking? It's just asking for the slope between, whoops, I'll let you guys do it. I want it 5.5, so you're going to look at 4 to 7, right? That's all it's asking. Are you starting to see the theme? Looks familiar. Looks like the very first problem we looked at. 2007 question 3 is just sparse data. We can't do, we will come back to this, we can't do part B. Also has to do with the intermediate value theorem, which we're not testing you on, but it's good to think about it. Okay, page 3, question 4. 2006, question 4. And notice I've got one from every single year. So you should see that common theme. It says, find the average acceleration. Now in my table, I have t and v. How do you find average acceleration? It's the change in v. This is what you do have to know. These equations you have to know. So the average acceleration is, and I want it where? T is between 0 and 80. So it's going to be v of 80 minus v of 0 over 80 minus 0. I'll read it out of the table. It's an average rate of change. It's nothing more than slope. 3 questions so far now have had just plain slope on them. Look at the next one, 2005, number 3. And we always start at the most recent ones and work backwards because they change them a little bit, although it's still pretty much the same. It says estimate t prime of 7. So what am I going to do? I'm going to do t of 8 minus t of 6 over 8 minus 6. Guess what? It's just slope again. Are they starting to feel more comfortable? It says t prime of 7. What's t prime? Which means what? Slope. And what says estimate? So you have to know what an average rate of change is. Average rate of change, we are going to have average value of a function coming up, but we don't know that yet, so you can't get too confused about that. Is the change in the y over the change in the x. It's nothing but more than slope. When they ask you for a derivative, if they say estimate, well, it's pretty close to that. Just an estimate. Okay, let's then look at 2004 question 1. This is why you want to do a bunch of these, because you're going to see the same question. Now here they didn't give us a table, but they gave us a formula. What is the average rate of change of the traffic flow from t between what, 15 and 10? What is it asking for? Slope. I want the average rate of change. Okay, Grant? I want the average rate of change for this one. So it's going to be f of 15, because they give you the formula. I'm not going to read it out of a table. So this is a calculator active problem. F of 10 all over 15 minus 10. Are you seeing the theme? They're all asking for slopes. Every single one. And when we do this in the spring, we have them all divided up, so we do all problems that look like this. So that when you go into the exam, notice there are always problems 1 and 2. You're going to say, I know this is going to be on there. You have to plug it in, but it's a calculator problem. Questions 1 and 2 are calculator. Usually 1, 2, and 3, but then they changed it last year. On the exam, 6 free response. And notice, like you got some A's and B's down here on the back page. So there was a little more you could do. It wasn't easy. 2003, number 3. This is a calculator active question. Plus, you don't know how to take the derivative of this thing. Not yet. And it says, find the acceleration. Well, how do you find the acceleration? What is A? Yeah, dv dt. So what you're going to do with this is do n derive. It's v of t. Then my variable is not x. If you want to type in x in your calculator because it's easier, that's the way to do it. But this is t right now with respect to t at t equals 2. That gives you A. And then it says, is the speed of the particle increasing? Well, you got to look at A of 2, and you got to look at V of 2, and you have to check the signs. We did that on the first problem. Okay, you guys, question? So this is a calculator problem. You may use n-derive if it's a calculator active question, always, to find your derivative. B, find all times in the open interval when the particle changes direction. How do you know when it changes direction? What do you, if you're driving your car and you're going to go from reverse to forward, what do you have to do? Changes direction. Velocity has to go from negative to positive, or velocity has to go positive to negative. In other words, what has to happen in between? B has to be 0. So, do I need a calculator to solve this? You think you do, but I don't think you do. You may use a calculator to solve this. But sometimes the calculator is worse. This is zero product property. Either t plus 1 is 0, which means t is negative 1, which doesn't make sense. Or, and I know you don't have a lot of experience with this, sine of t squared over 2 has to be 0. Now, what angles, the sine of what angles give you 0? I did this quickly in the last class. We have a little more time there. You got 0, you got pi, you got 2 pi. So whatever's in here, t squared over 2 has to equal 0, or t squared over 2 equals pi, which means that t squared equals 2 pi. Well, what's the square root of 2 pi? Square root of 6? 2 something, right? And my t is going to be between 0 and 3, so I want to look at this one. So t is equal to the square root of 2 pi. And what about that one? T squared over 2 equals 2 pi. So t squared equals 4 pi. So t is equal to 2 times the square root of pi. That's bigger than 3, isn't it? 4 times 3 is 12. It's bigger than 3. So this is the one you'd use. That's where it changes direction. But you would be allowed to use a calculator, so you'd get it anyway. The last one, how do you find the acceleration on the last one? This is 2002. Number 3. V is equal to the sine of pi over 3t. How do you find acceleration? dv. And you're going to evaluate it at t equals 4. And then they talk about the object speeding up or slowing down. So you have to find a of 4, and you have to find v of 4. It's a calculator active question, but you should be able to do it without. I don't like those. What are either both the statements true or false? Oh. Now, this pink one will get worked out. Scan it. It'll be up on Schoology. I don't think it's on tomorrow. I think it's in the part. Everything that we've covered here, you need to be able to do. We've given you ideas for what your test is going to look like. You know, if I've covered it in class, it's got to be important, right?